Welcome back to this course of quantitative finance. So, as we are discussing, we will wrap up the utility section and then start off with the investment and what we mean by rate of return and how rate of return is useful in portfolio analysis and where the concept of utility actually comes into the picture. And later on, we will proceed depending on what are the different type of portfolios you can formulate and what are the different techniques of trying to formulate and find out the prices of options. So, as we are discussing, the utility is basically the value or net value based on which a person invests. So, I am using the word investment because it is basically related to finance, but the utility is basically a value based on which a person takes a decision. So, now consider the utilities. If they are not known, what we do is this simply as here. Now, consider there are A and B are two wells, and consider for both A and B you consider you have some probabilities P and 1 minus P, because the sum of the probability should be 1. Now, with that scenario you place in front of a person and you ask him or her that whether that person will take that gamble or that non-deterministic scenario, or the person will basically choose a deterministic case or a value of certain C, which if you remember, the value of C is basically the value based on which a certainty equivalent based on which a person is absolutely sure that he or she will take that deterministic amount. Now, if a person is indifferent, so obviously the person would be able to say a particular value of C, and for a particular wealth A and B and certain probabilities P and 1 minus P or 1 P and Q. Now, based on the first case, you keep changing the values of P and 1 minus P. So, definitely there would be a tipping point at which the person would either change from the case from being an indifferent person to being a risk averse, or being from being a indifferent person to the case where he is risk lover, or any of one of these depending on where he or she is. Now, those, if you go back to this curve, so if the probabilities are known, obviously you know the case where the C value is. Now, if you consider the straight line, it gives you an utility function of which is linear. Now, if the value of linearity does not hold, if it is basically a quadratic one or some other thing, and depending on the characteristics of the person will slowly give you different points on the Cartesian coordinate which you see in front of you. Based on this, where you can basically mark the points to find an analytical set of points or practical set of points for that person, such that you are able to find out what is the exact value of C or what is the exact nature of that person, such that you can class him or her as a risk averse person, risk lover person, or basically a risk hater or an indifferent person. So, these are basically very simple analytical techniques. We would not be considering that in detail, but this is the methodology how you do that. Now, how would you find out the explicit form of the utility function as stated? So, consider that you have an exponential utility function and you ask the person that he is given a lottery with some 50% chance and some values as they are stated, that is one is 1 million, which is 10 lakhs, and another value is basically 4 lakhs. Now, in order to buy that lottery, the person would be either, if he or she is a risk lover person, so obviously the person would always be thinking that the expected value of that lottery would be greater than any concept of certainty equivalent. If the person is indifferent, the person would definitely be indecisive between these two scenarios, and if the person is a risk hater, obviously he or she would definitely prefer a value which is deterministic. Now, either given the value of the utility function, which is the power function, you now keep changing the value of a, small a, which is a parameter which you do not know. And as in the other example which he had given, where you draw it in a very simple geometrical fashion, draw a straight line which is linear utility, and then find out that portion of the graph whether it is above that or below that, and classify the person. You can basically do the same analysis to find out what is the estimated value of A, and based on which you can basically classify the person, that given that exponential utility function, what is the parameter of A. Now, we would like to draw an attention to all the students or who are basically taking this course, that how you find out the utility function is more of a study which is done in economics. We will only utilize the concept of utility in order to basically go into the depth of portfolio analysis and how optimization is done. So, rather than the techniques to find out, our main emphasis will be how you use the utility function. So, before we wrap up, if you remember for the utility case, if you remember we had mentioned that there were two important points. One was the point of non-satiation and one was the point where person can be either risk averse, risk lover or risk indifferent person. So, and there are other three important points which are not all, there are three important points of utility function which are known as axioms, that if you are basically, there are two different decisions. So, obviously a human being or a person, whenever there is any decision to be taken specifically in the finance area, the person would definitely have a decision whether he or she is basically indifferent between two decisions A and B, whether A is better, that means the overall utility for A is better than B, or it is basically vice versa. There is no confusion that how the grading would be done, that would definitely be clear with the human being who is going to take the decision. Next is that if there are 3 or 4 more than 3 different decisions, so obviously the ranking system would definitely be applicable, such that a person, if he or she takes A with respect to B, A is preferred than with respect to B and B is preferred with respect to C, then obviously the relationship of A and B, A and C should be such that the person would definitely take the decision A and not C. So, there is the linearity and the hierarchy of the ranking based on which a person takes a decision. And finally, that if you consider the concept of certainty equivalent, that will give you a concept that the person will be indifferent between two decisions if the certainty value is same, which means that if you have different type of gambles or different type of lotteries as shown in later on in this graph. So, what I am basically what I want to analyze is that if you have basically different types of utility functions. So, these are just theoretical values which I am drawing. So, obviously, it would mean that the person, if he or she is basically indifferent between two utilities based on their expected value, then both the utilities would basically give you the same benefit for both the person. Now, comparison between the mean variance of the utility. Now, till now I have not never uttered the word of variance. Now, you may be thinking why variance is important. So, consider this very simple case. Let us not consider the utility function as such, let us consider a simple distribution. So, these are normal distribution which you know that, and there is another normal distribution where both the mean values are same. So, if you consider the mean values, you will basically have the expected values which is same for both the cases. Now, if I am trying to compare two different utilities, our main concern is not now expected value, because the expected values are same. That means the utility would give you the same certainty values. But what is of more concern is that what is the dispersion or the diversions between these two distribution, based on the fact that if for one case, if the diversion is very high, then the variance, which is the second moment of the distribution, would be higher value, and for the other case, the second moment, which is the variance, would be a lower value. So, hence we will first counter, this is the first time we are encountering that given a utility function, given a decision, if both the expected values are same, there may be cases where we will be taking a decision based on the variance, which is the second moment. And this is very important, that once we come to the case of portfolio analysis, we will see that how both expected value and variance will be utilized from the perspective of a decision maker, such that you are able to rank different portfolios in a very logical manner. So, consider this. So, consider now your question would be, before I give an example, your question would be, what if somebody loves risk and somebody hates risk, or somebody is basically willing to take a decision based on the expected value and somebody is willing to take the decision based on the variances, which is the second moment. So, our main concern would be, rather than only concentrate on the expected value, or rather than only concentrate on the value of the variance, we will try to basically take a ratio of the expected value to the variance and rank them from the values where the ratio is from the highest to the lowest, if you want to basically take a decision which is always positive. On the other hand, you can also do the same scenario analysis in different way, like rank the variance with respect to the expected value. That means, take the ratio of variance to the expected value and rank them from the minimum to the maximum, such that if the ratio of variance to expected value is the least, that is the best one decision, which will basically be favored by the decision maker. So, we will come to that later on, and if you see these equations which are given. So, given that you want to find out the ratios of the expected value to the variance and so on and so forth, we will see that how, given the distribution is normal, we can easily find out using the simple normal distribution tables or the z values. So, we will come to that in details later on. Now, consider finally, to wrap it up, consider you have a quadratic utility function. If you remember, I mentioned that very explicitly, that given two utility functions or two different decisions, any returns for the particular stock or for a particular financial scripts, if the returns are normal, then definitely you know the utility function is quadratic, and vice versa. So, consider that you have a quadratic utility function, and then you have basically the outcomes in scenario 1 and outcomes in scenario 2. So, what you do is that you find out the probabilities, and accordingly you can either rank them according to the expected value, or rank them according to the minimum variance, or rank them according to the case where expected value to variance is the highest, or variance to expected value is basically the lowest. So, as we were saying that if you remember that you will basically rank different decision based on the expected value, which was basically certainty value. So, if you have on the left hand side, there are different type of lotteries, and the outcomes are W1 to W4 for these 4 scenarios which you have, and the probabilities are P1 to P4, such that the sum is always 1 of the probabilities. You can break it up into basically lotteries, such that at the end of the day, what actually matters is basically the expected value or the certainty equivalent. Now, with this decision, we will first start that we will encounter in the case of portfolio analysis, which is an area of huge importance, where somebody tries to utilize the concepts or different type of mathematics and statistics in order to analyze the topics of financial investment. And for that, we will try to basically go through different techniques, such that the concept of optimizations and concept of statistics are definitely used in a very simple manner in order to find out what are the different type of portfolios, and how you find out the expected value and the variance of the portfolios in order to basically find out the so called optimal portfolio, which is best for one decision maker. So, we will for the first time we will basically consider that there are some sets of financial assets, and by the word financial assets we will mean only some scripts. Obviously, they can be gold, they can be different type of bonds, they can be different type of options. So, all these words which I am using for the first time in this lecture series, apart from the fact that we did mention about them then when we were discussing the syllabus, we will try to restrict our discussion in the initial part to the very simple examples, such that trying to analyze the problem later on becomes much more easier for us if we have understood the simple concept in a very nice manner. So, consider that we have only financial assets. So, given financial assets, say for example stocks. So, we know that if you have the stocks, that at the beginning of the day you have basically the opening price, and at the ending of the day you have the close price. Obviously, there is a maximum value, minimum value, amount of volumes which are sold and bought for these scripts. They are definitely important for us, but to make our life simple, we will only consider the closing price of a particular stock, or the adjusted closing price, whatever it is. Now, it should be remembered that as per the case, only prices are not important. What is important for us is what is the change or rate of change of the prices per day, such that depending on the upward movement and the downward movement of the prices, we can make a decision whether that investment or that particular amount of money which you are going to invest in a particular stock, whether that is positive or benefit of positive benefit or negative benefit to us, depending on what our outlook is. Now, remember another thing, when I am using the word outlook, it means basically the person is of what type. Does he want to basically take a decision based on which he or she wants to minimize the risk, or is that person he or she basically wants to maximize the return, or some different combinations depending on whatever the outlook of the person is. Now, I would request later on, definitely we will encounter all this data, but I will request all the different persons who are taking this course to have a look at the closing price of different stocks like S&P Nifty, which is you can find it from the NS India. You can find out the interest rate or the yield rate, which is the 91-day government bills. We will consider that how government bills are basically the values are found out, which is the risk free interest rate. The word risk free interest rate will come to that later on also, and that can be found from the Reserve Bank site also. Then we will also try to basically find out how the Indian rupee to the US dollar, Indian rupee to the UK pound basically they fluctuate, or what is the trend, or how do they look like. So, given that fact that you are able to basically plot those data points or plot those curves on an Excel sheet, that will give you a good feel that how does basically the price fluctuate. Based on the price fluctuation, you can find out the rate of returns, and based on the rate of returns, we can find out what are the portfolio combinations are. Now, for borrowing money, we always need some sort of collateral. So, we will consider that for when you are basically investing any particular money, for the initial case we would not consider any collateral. Collateral means the amount of money which you are giving as a security, but later on we will see that when options are there, when forwards and futures or different type of combinations are there, there is a concept of margin money and margin account which is there, which is kept as a security for any positive or negative price fluctuation of those particular options. We would not consider that. Number 2, we would not consider here for the time being is what are the implications of the taxes. Number 3, we would not initially consider what are the actual amount of money which is being paid to the broker. Like when I go to the stock market and basically either I buy or sell particular stocks, so obviously I have to give some money back to the broker in order to get his or her services. We are not going to consider that. We are also not going to consider any price fluctuation depending on any discount being given. So all these things will be brought into the picture, and our problems will be made much more realistic once we are able to appreciate the actual theoretical concept in all its implications. So we will consider very simply a security is a piece of paper which is basically some part of that stock which is being bought and sold, or that company has floated a particular stock and that is being bought and sold. Also we would not be considering stock split. So stock split is basically our stock was there, depending on how the dividend and how the company is doing, that the stock would be split into 1:2 or 1:3. So we would not be consider that, as I mentioned, that in order to make our life simple for the first set of problems. So consider that the rate of return. So we have basically two types of rate of returns. One would be basically known as the rate of return which is small r, and remember the small r will be utilized for all the sets of problems, and then would be another rate of return or capital R. We will consider both of them in our problem, but the actual solution based on which we will try to solve the problem, whether we take small r or capital, would be the same. So as we were discussing that what is important for is basically to find out the rate of return, whether small r or capital R. So there is actually, when you solve the problem, there would not be much of a difference in the way you solve the problem, considering whether it is small r and capital R, but we will consider that all our problems which you are going to solve later on would be based on the fact that you want to find out the rate of return which is small r. Now if you see to the formula, small r basically means that given the prices or given the investment, let us consider for the initial time being, there is the investment which you are doing at time t is equal to 0, consider is today, and you get a return based on whether the prices are increasing or decreasing. You get some output which is given as I suffix 1 or suffix 2 depending on whether it is day 1 and day 2. So consider if it is day 1, so obviously you have I suffix 1 is for day 1 ending investment which you get back, which you want to get back if you basically close your position, and I0 is the actual amount of investment which you do at the beginning of today, which is 0th day. So what is the actual positive or negative return in amount terms would be I1 minus I0, which is in the numerator, and if you want to find out the rate of return, it will basically be a percentage sense, in the sense that given that amount of investment which you are doing at I0, what is your actual percentage of return which is given by I1 minus I0 in the numerator divided by I0. So that will basically give you the value of R. So if you consider the price of the stock, if the price of the stock is 100 and tomorrow the prices of stock is 110, so obviously in numerator you will basically have 110 minus 100 which is plus 10 divided by 100. So obviously R would be positive. Now if I mention that the prices have decreased from 100 to 90, it will be basically minus 10 in the numerator divided by 100. Now if you consider these are the R's, remember one very important thing, if you mention the rate of return having normal distribution, which means that the values of R, if you plot them and if you consider them to be normal distribution, then, and if R is a random variable, then plotting the distribution of R would give you basically a normal distribution with a certain mean, certain variance and so on and so forth. And which would mean, again if you go back, we had mentioned that the utility function was quadratic, such that it means that investment decision which a person is making is based on the fact that the person has a quadratic utility function. We will come back to that later on as we proceed. But in actual theoretical sense this may be true, but in the practical sense that is not true, because there are different type of non-normal distribution which are utilized, and in practical sense they give you much better results. Now if you see this simple line diagram, so now consider the line, why I am highlighting on the fact this is a line diagram, because if you consider a static model in the sense that only one time period is there, so the time period is basically from I suffix 0 to I suffix 1 or 2 or whatever it is for the time period. Here if we consider I suffix capital T, that means if you invest the money at time t0, In between you are not going to invest anything, you are not going to take out any money, and at the end of the day or end of the time period, which is capital T, your total investment which is worth for the initial investment of I 0, it will be I suffix capital T. So hence you can find out the value of R. R would be basically the R0 or R1 depending on how you are trying to basically define it. So if now there are two different time frames, that means I naught for day 0, I1 for day 1 and I2 for day 2. So obviously the returns for the first case would be I1 minus I0 divided by I0. So what you have is that there are two different time frames. Let me go back. So basically there would be two time frames, one which is 0, another is 1 and another is 2. So here we have only the first instant. So if you have basically I0, I1 and I2, so this value would be given by R1, which is I1 minus I0 in the numerator divided by I0. For the second one, which is R2, it will be I2 minus I1 divided by I1. So what I was talking about, the distribution being, this distribution would basically have a normal distribution. So we will come to that later on also. Now consider that if you have only capital R, which is the total return, so obviously it will be given not by the minus value or the difference, it will be given the value of returns or the total value which you have in your pocket for any investment. If you close your position, that means you either sell it or buy it, divided by the actual initial investment or amount of money which you had, which is basically I0. So for the same diagram, if you have two different things, so this is time 0, time 1 and time 2. So the capital R would be I1 divided by I0 for the first instant. So this would be R1, and for the second instant it will be R2, I2 divided by I1. So this would basically the ending period and the beginning period wealth. Wealth means amount of money which you have. So this on a time scale of only the single time period, you have the initial input and the initial output of money which had gone into the decision or making the decision. Now, as if you remember, we have mentioned that the risk free interest rate, small r suffix f or capital R suffix f, f means risk free. So consider very simply that this is the government bond for 90 days based on which you can find out what is the risk free interest rate. In the very theoretical sense, the word risk free means that if you invest in those type of investment, your actual variance is 0 because there is no risk. Still there is some expected value for the return. So this will be very helpful for us to analyze different type of decisions based on which a person will either invest in some decisions which are probabilistic, which are non-deterministic, such that their expected value or the average value is more than RF, and if in case some the expected value are less than RF for some non-deterministic cases, obviously the person would not be willing to invest in those decisions. So we will come back to the RF value later on, either in the portfolio case or in the drawing the efficient frontier or whatever we encounter as we proceed with the course. Now also later on we will consider long term bonds. For the reason being, for the long term bonds, the risk based on which you are trying to basically analyze long term bonds or the interest rate of you, or you consider the overall variance, or if you consider the expected value, time would have a great effect on the interest rate or what we call basically the volatility or the risk or the variance. So we will consider later on also that if there is a huge time frame, that means say for example for 1 year or 2 years, then the long term, and if you have long term bonds in your portfolio or in your kitty or the box based on which you are trying to basically make your portfolio, so there the interest rate would basically play a big role in how you want to find out the overall effect of long term bonds, because those interest rate which will be calculated are fluctuating. If they are fluctuating, you have to basically take the optimum value of the interest rate, which is basically in a simple sense the expected value of the interest rate, not the actual R, is basically the expected of the value of R which you find out for a whole time period. Now we will also consider later on that financial intermediaries are basically the houses, the banks, the clearing houses, the stock market, where people come and sell and buy any particular financial instrument. So if you remember in the first initial lecture when we discussed, we had basically a demand and supply. So those demand and supplies are based on the fact that there is some number of buyers and sellers. Consider that it is small n, and small n is not small. Small in the sense there are number of players in the market. Small n, I mean this. So this number of small n is not small in number, is basically it is such that any price fluctuations in the demand and supply would be immediately affected in the market, such that all the players who are there in the market have exact information on the prices, such that any fluctuation of the demand, any fluctuation in the price P of that particular stock would be available to all of them, and such that everybody can take a rational decision based on his, on the fact that what that person characteristics is from the point of view of whether he or she is a risk lover, whether he or she is a risk hater, or whether the person is basically a risk indifferent person. So, now we will for the first time encounter the concept of risk return and how risk and return is utilized in order to basically analyze any investment or analyze any decision. So, now in 1952 Markowitz, Harry Markowitz, who was a Nobel Prize winner in economics, he basically proposed a very interesting concept where for the first time the concept of a particular investment from the financial perspective was basically clubbed into two important points. One is the expected value, one was the variance. So, given any particular financial instrument, you can basically club that set of information into only two different bullet points. One is if the expected value of a particular stock is higher, obviously you will try to invest more in that. If the variance of a particular stock is lower, obviously you will try to invest in that particular stock also. So, our main concern would be given the expected value and given the variance of particular stock, we will try to basically find out that how you can combine these different type of stocks to form a portfolio such that you are able to optimize your overall output. What that output you will see that changes from person to person such that you can basically form the optimal portfolio for a human being who is willing to make a decision. So, we will consider for the first time the concept of return and risk. Risk initially I will use as a term of variance. We will use the formula later on, and later on we will see also that how the higher moments, which is skewness, kurtosis, are also used in a very big way, though in a theoretical sense, such that you can formulate different type of portfolio based on not only the first moment, which is the expected value, not only on the second moment with the variance, but also on the fact that the information related to the third moment or the fourth moment, which is skewness and kurtosis, can be utilized accordingly. Now, for any outcome here, if you are assured that if there is 100% return, obviously it is a deterministic case. But if you consider the prices of the stocks or the properties of the stock, they have some distribution. We are not going to consider the distribution per se as such. We will only consider the distribution is there for the random variable r, small r, which we just discussed. And we will consider that random variable has some characteristics such that given n number of different type of investment which you have, they have the characteristics such that R1 will be the actual random variable which will denote the return of the first stock, and sigma, I am using the variable for the first time, sigma 1 would be the standard deviation of the particular first investment which you are doing. Similarly, you will basically have R2, sigma 2, correspondingly you will basically have Rn, sigma n, depending on how many different type of such financial scripts are there. Now, for an outcome which is random or probabilistic, so we will basically have the first and second moment, which is the expected value and the variance, which will give you us the whole amount of set of information about that particular stock or a particular financial instrument which we have. Now, also as we discussed that expected value, if you consider, it is basically given an average value. But what we mean by an average value, we will come to that within another 2 minutes. And what we mean by the dispersion of the variance, also we will discuss that in little bit depth, in the sense that how they can be calculated given different type of data sets which you have. We will later on also find out that how skewness and kurtosis given these formulas can be utilized for different type of theoretical portfolios which one wants to basically formulate, given that there are different type of stocks such that the first moment and the second moment does not give all the information for the portfolio, so as that we will be tempted to utilize the higher moments to find out the characteristics of this portfolio or the particular stock. Now, consider very simply that if you have two discrete variables, one is a discrete variable and one is a continuous variable. Discrete variable in a very simple sense means that it can take only discrete value. Consider you roll a die. So, the values of the face of the die when you play the game of Ludo is either 1 or 2 or 3 or 4 or 5 or 6. So, obviously, the corresponding value or the probability of getting any face is 1/6 depending on how many outside outcomes are, and we will consider that is an unbiased die. So, for example, when you toss a coin, the corresponding probabilities, it is half and half for a unbiased die which is a head and a tail. So, we will consider either the discrete case, and for the continuous case where the random variable can take any value, we will consider the probability distribution to be continuous, and or the random variable can take continuous values. So, if you consider the random variable x with a suffix I depending on how many such values which you have, and f of x as is noted as the probability distribution function or the probability mass function based on which you can take a decision whether it is basically a discrete or a continuous the random variable. The expected value would be given by the formula as given here, which is summation of the multiplication of all the x's and f of x, which means that if you have basically the die which you are rolling, so all the random variables which are the outcomes are either 1 to 6. So obviously you have 1, 2, 3, 4, 5 which are the different random variables. So when r is 1 you have 1, when r is 2 you have 2. For the case when I am using r as a random variable, in this case if x1 is 1, then the corresponding probability is 1/6. If x2 is 2, then the corresponding probability is 1/6 and so on and so forth. So if I want to find out the expected value, what I will do is that I multiply the random variable, its realized value, that is the realized value which you see, multiplied by its corresponding probability and add it up. So obviously it will be 1 into 1/6 plus 2 into 2/6, so on and so forth till the last value which is 6 into 1/6 and find out the expected value. Now if I want to find out the basically the variance would be, in this case would be, so once you find out the expected value and consider that the expected value comes out to be, say for example E of x, whatever the value is depending on what type of distribution which you have, you want to find out the variance. So variance would be, in this case when you are basically rolling the dice, it will be the random variable realized value which is 1 minus its expected value. So it will be 1 minus E of x whole square multiplied by the corresponding probability is 1/6. 2 minus Ex, which is the expected value, whole square into 1/6. Once you find out that value, sum it up, you will basically have the variance. So remember the variance is a square of that value and obviously it is positive. Now if you have continuous variable, then this summation sign gets replaced by the case where you have basically the integration. So the hence for the case when it is a continuous distribution, given the random variables can take any values between -infinity to +infinity, expected value will be found out using this formula, which is integration, and the variance would be found out using this integration. Just a note before we proceed, that given this expected value and the variance, a very simplified formula which we will see later on would be this. So say for example you have variance is equal to expected value of x minus e to the power x. So this is the exactly thing which here. So here e and the summation which you are using is the same thing. So what you can do is that if you expand this equation, the first term will be x square, the second term would be minus of 2x into e to the ex. That means you are basically multiplying, the first term would be x square, second term would be ex into x, and the third term would be basically ex whole square. So now this is the term which is inside the bracket. If you take again the expected value of this, so obviously at the end of the day what you have is basically e to the power x square, which means the expected value of the square of the random variable minus, so if you basically find out these two values, so obviously it will become minus of ex whole square. That means the first term is finding out the expected value of the square of the random variable, and the second term is basically finding out the expected value and then squaring it up. So we will see that later how it can be utilized in order to find out the variance for different type of random variables depending on the problems which we solve. Now consider for any different n number of assets. If there are n number of assets, what you have is basically n different random variables. So if there are n different random variables, each will basically have expected value, each will have basically the variance, considering that we have utilized those formulas. So what is also required is basically the correlation coefficient of the covariances existing between these n number of random variables. So say for example if we consider a matrix, so matrix is basically, for the simple case, if you have n number of assets, we consider n cross n matrix. So there are basically n number of rows and n number of columns. Now what is important for us to understand is that if you basically write the variance and the covariance matrix of all these n number of matrices, we will be able to get the covariance of the portfolio, based on which we are able to find out actually the variance of the portfolio in the later on. So we will basically continue that discussion in the later sections.